Hello dear students, this is Santosh sir and welcome back to the simplified chemistry class. Dear students, today we are discussing on one of the most important topic in PU2 or in 12th chemistry. And you know the name of the topic which has a lot of weightage in our final exams as well as in our competitive exams. So today we are learning on electrochemistry. Let us try to understand the word electrochemistry. To understand this word electrochemistry, we are considering two simple reactions. And the very first reaction that I am writing is, you know this reaction very well. When sodium is brought in contact with the chlorine, electropositive element sodium reacts with electronegative element chlorine very fast. As soon as you bring the contact between the sodium and chlorine, immediately there is a formation of sodium chloride. See, to balance equation, I am going to multiply NaCl by 2. Similarly, sodium by the 2, equation gets balanced. Now, when I look at the charges, sodium charge on both reactant side as well as the product side. Sodium charge is 0 as it is in the elemental state, and here its charge is plus 1. It means what the sodium is doing? Sodium is losing 1 electron. And you know that loss of electron, we are calling it as oxidation. At the same time, the electron lost by the sodium is gained by the Cl, and Cl is converting from the charge 0 to the minus 1. It means Cl is gaining 1 electron, and you know that gain of electron, we are calling it as reduction. So this is a spontaneous redox reaction. The reaction which occurs on its own, we are calling it as a spontaneous reaction, and this is a spontaneous redox reaction. Now see the beauty of this reaction. By any means, by using a wire, if suppose, imagine that we are able to transfer the electron lost in the oxidation part to the reduction part using a wire externally. You know that whenever the electron flows externally through the wire, definitely there is a generation of electricity. So we are generating electricity by making the electron lost by sodium to reach the chlorine by passing through the wire. But practically, students, remember, this is the reaction which is very fast and we cannot do such electron transfer through the wire. But since it is a simple example, to understand one important term called galvanic cell, or this galvanic cell is also called as electrochemical cell, I have taken this example. So we understood if we are passing the electron lost in the oxidation part to the reduction part using a wire, definitely we can produce electricity, and this is what normally happens in our batteries which we use in our day-to-day life. Such a cell, such a device, we are calling it as galvanic cell or electrochemical cell. So what is a galvanic cell or electrochemical cell? This is a device which converts chemical energy of spontaneous redox reaction, chemical energy of spontaneous redox reaction, this one, to electrical energy. This is the first part we are learning in electrochemistry about the galvanic cell, the device which converts chemical energy of spontaneous redox reaction to electrical energy. Let us move further. Okay, let us move on to the second reaction now, and we are trying to understand another part of electrochemistry. Whenever we add NaCl to water, you know what is going to happen? This is the reaction I used to give in my regular class to make the electrochemistry concept clear. And I have seen most of the students are writing the products as NaOH plus HCl because the reverse reaction we have studied in the form of titration. But remember, this reaction is not possible because this is a non-spontaneous redox reaction, the reaction which cannot occur on its own. Okay, let us study then how to make this reaction occur. When I add NaCl in the water, NaCl splits into Na plus and Cl minus. This is the dissociation. We got Na plus Cl minus ions. From NaCl, water, part of the water is present as H plus and OH minus. We got Na plus H plus ions as cations, Cl minus and OH minus as anions. Now, imagine that we are passing electricity through the mixture. Pass electricity through the mixture. When you pass electricity through the mixture, check the reaction first occurring at anode. Now here, anode corresponds to the positive electrode. Now at the positive electrode, we find anions, and the ions are Cl minus, OH minus. Now there is a competition between Cl minus, OH minus. For oxidation, always remember at anode there is oxidation. And how to remember this? Whenever I am dealing with a class, I used to give a trick. You just see, to remember oxidation always occurring at the anode, we can remember in this way, ox, and before writing ox, we write an. According to the English grammar, whenever a word is starting with the vowel, before that you should use that an. So I remember an ox as anode oxidation. So this is a memory trick. Always oxidation occurs at anode. To remember that, you can remember in this way, an ox. Now come back to this. Cl minus preferably undergoes oxidation. Cl minus ions lose electrons and get liberated as chlorine gas. Now, the electrons which are lost in the anode, they are gained at the cathode. Cathode here, it is the negative electrode. It's very important to remember the charges of anode and the cathode. Now, at the cathode, we find cations. And which are the cations we are having? You just look at the cations. I have written the ions here. Na plus and H plus. Again, there is a competition between Na plus, H plus. Out of this, H plus preferably gains electron. For that, there is a reason we will see in our next video later. Now, whatever the H plus ions we have, these H plus ions, they gain electrons and get liberated as hydrogen gas. At the anode, there is a liberation of chlorine gas. At the cathode, there is a liberation of hydrogen gas. And here, the reaction occurring at the cathode is reduction. How to remember this? Way we have a red cat. This is the red cat. Cat for cathode, red for reduction. So this is a memory trick. In this way, we can remember the reduction occurring at the cathode. Now come back to the remaining ions. Whatever the remaining Na plus ions and OH minus ions are there, they are made to combine so that there is a preparation of sodium hydroxide. We got the products which we have written in the beginning. And remember, these products we got by passing electricity. I'm going to write the reaction again. Now check the reaction which is not possible in the beginning. NaCl plus water gives NaOH plus HCl, hydrogen chlorine. They combine to give HCl. This is possible only on passing electricity because this is a non-spontaneous redox reaction. Now see students, what we have did. By using electricity, we carried some chemical reaction, and this is a non-spontaneous redox reaction. Such a device, we are calling it as electrolytic cell. Electrolytic cell is a device in which electrical energy or electricity is used to bring non-spontaneous redox reaction. We came across two types of devices. One is galvanic cell, which converts chemical energy of a spontaneous redox reaction to electrical energy, and electrolytic cell, in which electricity is used to bring non-spontaneous redox reaction. Electrochemistry is a branch of physical chemistry which deals with interconversion of chemical and electrical energy. Chemical energy used to produce electricity. As I told you, this happens in the batteries. And you know, this device is called galvanic cell. And the device in which electricity is used to carry out the chemical reaction is called electrolytic cell. So this much is about the electrochemistry definition. In our next video, we are focusing on the galvanic cell. Thank you very much and bye-bye.